Hello students, welcome to Stuti Academy. In this video, I'll explain matter in our surroundings chapter to you, which is first chapter of chemistry. So in this chapter, we'll study about matter, its states, and what are the particles present in it, what kind of arrangement do they have. First of all, we need to understand what is matter. As we all know, in this universe, ample of things are present, and these substances are made up of certain material, and those substances or materials we call them matter. If we talk about matter, matters are also made up of tiny particles. The particles which are present in matter, they are continuously moving and they have certain spaces between them. That is why they keep on moving randomly. And these particles which are present in matter, they attract each other. So these are the properties of matter. What are those properties which we are talking about? The properties of matter are, they are made up of tiny particles, they occupy space and have some mass, they have some spaces between them, and they continuously moving, and particles of matter attract each other. Now, this type of question asked in exam on the basis of this topic, why is light not considered matter? As I told you, matter is a substance that occupies some space and has mass. But if we are talking about light, light neither has a mass nor occupies any space. That is why light does not considered as a matter. Question number 2 is, what is matter? Anything that has mass and occupies space is called a matter. Due to the arrangement of particles which are present in matter, matter exists mainly in 3 states. And these 3 states are solid, liquid, and gases. First, I'll explain solid state and what kind of arrangement of particles are present in solid. Just see this diagram in which the arrangement of particles are there. If we see these two particles, suppose this is particle 1 and this is particle 2. The spaces between these particles is very less. As a result, it has a strong intermolecular forces between them, and very less intermolecular spaces are present. That is the reason solids have definite shape and they are rigid in structure as well. The intermolecular forces present between the particles are very strong. That is why they require high temperature to break that force. So solids have high density, high melting point, and high boiling point. Due to its rigid structure, solids cannot be compressed and they cannot be flow. So these are the properties of solid state of matter, and this is due to the arrangement of particles in the solid state. If we talk about liquid state, in liquids, the arrangement of particles is somewhat like this. The particles are far away from each other in comparison with the solid, and due to this they have weak intermolecular force and large intermolecular spaces are present. That is the reason liquids do not have a definite shape and volume. Density of liquid is quite low. They have low melting and boiling point. Liquids can be compressed easily due to more intermolecular spaces and less intermolecular forces of attraction. Liquids can flow easily. If we pour some water on a table, water can easily flow. But if you keep book on a table, book cannot flow. It remains as it is. So this is the difference between solid and the liquid state of matter. Now the third state is gases. In gases, the arrangement of particles is somewhat like this. the particles are very far away from each other. As a result of which they have very weak intermolecular forces of attraction and very large intermolecular spaces are present. As a result, they do not have any shape and volume. They take the shape of the container in which you will fill gases. Density of gases is very low. They are highly compressible. If you inflate a balloon, you can easily press the balloon. The air which is present in it, you can easily press it. So, gases are highly compressible and gases can easily flow. Suppose your mother is preparing food for you in the kitchen. The smell of the food goes to the other corner of the room. This is due to the this property of gases that they can flow, and one process is responsible for this, and the process is diffusion. With the help of this process, gases can flow. Diffusion is a process in which there is a movement of gaseous particle from higher to lower concentration. And if we compare these three states of matter, solid, liquid and gases, solids have strongest intermolecular force and gases have weakest intermolecular force. Solids have less intermolecular space, liquids have large intermolecular space and gases have very large intermolecular spaces between the particles. Solids have definite shape and volume, liquids have definite volume only, no definite shape. They will take the shape of a container in which you will pour liquid. For example, if you will pour liquid in a glass, it will take the shape of a glass. And if you will pour the same liquid in a bowl, it will take the shape of a bowl. Gases, neither they do not have definite shape nor definite volume. Solids have high density, melting point and boiling point due to the strong intermolecular forces. Liquids have low density, melting and boiling, and gases densities are extremely low. Solids cannot be compressed due to its rigid structure. Liquids can be compressed and gases are highly compressible. Solids cannot flow, liquids can flow and gases can also flow. When particles are moving in these states, they follow a zigzag path. They do not flow in a particular pattern. Some particles move here, some move there. So, they follow a zigzag path. Zigzag path. And this zigzag path, or they are moving randomly, and this kind of movement is known as Brownian movement. When particles follow zigzag path or they follow randomly or they are moving randomly, so this kind of movement is known as Brownian. Apart from these three states, two more states are there. First is plasma. Plasma is a state in which particles are highly excited, they are super energetic. For example, gases present in fluorescent bulbs and tubes. It contains plasma and they can glow easily, and this glow is due to the high energized particles which are present in. So, that is the example of plasma. Another state is Bose-Einstein condensate. And it was discovered by Satyendranath Bose and Albert Einstein. In this Bose-Einstein condensate state of matter, when gases cool at a very low pressure and temperature, then it becomes a Bose-Einstein condensate. So, these are the 5 states of matter: solid, liquid and gases. Apart from these, 2 states are also there, that is plasma and Bose-Einstein condensate. Now, what type of question asked in exam? First is, what happens when an inflated air balloon is pricked with a pin? Name the property of the gaseous state exhibited by this observation. As I told you, gases can flow easily due to the process of diffusion. Diffusion is a process which is responsible for the flow of gases from higher to lower concentration. So when we inflate balloon, when we fill air in a balloon, then we apply some pin in it, and that gases comes out from the balloon and it get burst. So the coming out of the gases and mixing of that gas into the atmosphere is due to the process of diffusion. Next question is, what is meant by Bose-Einstein condensate? As I told you, apart from three main states, two main other states are also there, plasma and Bose-Einstein condensate. So this was discovered by Satyendranath Bose and Albert Einstein. In this, the gases are cooled at a very low density and at an extremely low temperature. Now question number B part, why are gases compressible but not liquids? Because the intermolecular space in the gases are extremely large, and in liquids intermolecular spaces are there but they are less in comparison with the gases. That is the reason gases are highly compressible than liquid. Now what will happen if we provide any temperature or pressure to a matter? So there is a change in the states of matter. Matter can change its state, or we call it conversion of states of matter. Matter can change its state from one form to another form by applying heat or by providing temperature or by applying some pressure also. Here, when we provide heat to a solid state, it changes into liquid, and when we continue apply heat, then liquid changes into gaseous form. When we decrease the temperature, gases changes into liquid and liquid changes into solid. So this is the conversion of different states of matter from one form to another form. Or we can say that temperature plays a vital role in changing the states of matter. If we increase the temperature, solid changes into liquid, liquid changes into gases. And this is possible because when we apply temperature or when we increase temperature, when we provide heat, the particles which are present in a particular state of matter, they start gaining energy and start vibrating from their position. Then they convert into different state. And if we reduce the temperature, those particles which were far away from each other, they start coming together and they start changing into one form to another form. Now, what type of questions asked on the basis of this topic? These are frequently asked questions in the exam. Question number 1 is, why do solids expand a bit on heating and contract a bit on cooling? As I told you when I was explaining the arrangement of particles in a solid, when we provide heat or we increase the temperature, then in that case the particles start gaining energy and they start creating some space between them. That is the reason why they expand on heating. But when we are providing heat, the particles are moving from one place to another, but they are not leaving their mean position. That is why they contract on cooling. And this is possible due to the strong force of attraction. And now second question, draw a diagram to show interconversion among states of matter. In this diagram, as you can see, solid changes into liquid on fusion, liquid changes into gases on this vaporization, gases changes into solid on sublimation, or liquid changes into solid on solidification. Gases changes into liquid, and the process responsible for this is condensation, or gases can directly converted, or solid can directly converted into gases. So this is due to the process of sublimation. What are these processes? Suppose this is a beaker in which some ice is present, and when I provide heat to it, the particles which were very close to each other due to strong intermolecular force of attraction, they'll start leaving the space between them and they start gaining some kinetic energy. As a result, they convert into vapors form and changes into, first ice change into liquid form, then this liquid changes into vapor form. And when we keep any lid on this beaker, so the liquid which goes up in the form of water vapors, it gets collected on that lid and convert into liquid form again. So solid first changes into liquid, then liquid changes into gases, and gases again changes into liquid. And if we keep that liquid in a fridge or reduce the temperature, that liquid again changes into solid. So this is how one state of matter changes into different state of matter, increasing temperature or decreasing temperature. Next is melting point. Melting point is at that temperature at which solid starts melting at a given atmospheric pressure. And boiling point is that temperature of the liquid in which it starts boiling and converts into vapor form. Boiling is also known as bulk phenomena, because when boiling takes place, the particles which gain more kinetic energy, they start going up and converts into vapors form, and it happens in a bulk form. This is the reason boiling is called a bulk phenomenon. Now, what type of question comes from this topic? Define boiling. There you have to give the definition of boiling only, and why is boiling considered as a bulk phenomenon. What is boiling? Rapid and breaking of bubbles in the bulk of a liquid, which means when we provide heat to a liquid, the particle starts gaining energy and they start vibrating and convert into the liquid, this vapor form. So this breaking of the particles or creating more space between the particles by providing heat is known as boiling. And when this boiling process takes place, the liquid in bulk start gaining more energy, which is as a result of which they are capable to convert it into vapors form. That is why it is known as bulk. Latent heat. Latent heat is the heat which is used to convert one state of matter into another state, or we call it hidden heat also. Another name of latent heat is hidden heat, because it only useful in converting one state into another state. It does not help in increasing the temperature. For example, here is a beaker. I'll draw again. Here is one beaker in which some ice is there, and I'll use one thermometer here. This is thermometer. First, I note down the temperature of the thermometer, this ice, and it is 0 degrees Celsius. When I provide heat to it, the temperature in the thermometer still 0 degrees Celsius until and unless the entire ice or which is in the solid form converts into liquid form, which is water form. Once it completely converts into liquid form, then only there is raise in temperature in the thermometer. So this heat which is used to convert solid to liquid is known as latent heat of fusion, or in general the heat which is used to convert one state of matter into another state without increasing temperature is known as latent heat. And this latent heat is of two types: latent heat of fusion and latent heat of vaporization. So here this heat is latent heat of fusion, in which solid changes into liquid without increasing the temperature, and we see the increase in temperature only when the entire ice changes into liquid. In the meanwhile, there is no change in the temperature, and this heat is known as latent heat of fusion. Now, latent heat of vaporization. In latent heat of vaporization, again I'll take one beaker. Now this time I'll add some water into it and provide heat. When I provide heat to this, again thermometer is here. The reading in the thermometer is same, which is the temperature of water. When we provide heat, when we provide heat to this liquid, the temperature in the thermometer does not rise until and unless it starts boiling. When it starts boiling, then it converts into vapor form, and then only we'll see there is a rise in the temperature in the thermometer. So this heat which is required to change 1 gram of a liquid to a vapor at atmospheric pressure is known as its latent heat of vaporization of that particular liquid. Now question comes based on this topic. First question: a student heats a beaker containing ice and water. One beaker is there in which ice and water is present. He measures the temperature of the content of the beaker as a function of time. When he measures the temperature with the thermometer of this content or the substances which are present in a beaker, which of the following figure would correctly represent the result? Justify your choice. As you see, 4 diagrams are given. Water and ice, these two things are present in a beaker, and when ice and water they both are present together, they attain an equilibrium. They attain an equilibrium. The temperature is 0 because the temperature of the water and the ice by after attaining equilibrium is 0. When we heat the mixture, due to the latent heat, when we heat the mixture, the ice changes into liquid, but it will not show any rise in the temperature until the entire ice changes into liquid form. So this D1 is the correct one, because as you see here, the temperature remains constant and this is the latent heat, because until the entire ice changes into liquid, then only there is a rise in the temperature. So that is why D is the correct option. Now pressure also plays an important role in changing the state of matter. So first of all, the effect of pressure on the matter. If we apply pressure on the particles of matter, the particles which are present in the matter, they start coming together, and then there is a result of change of state of matter. Example for this is carbon dioxide gas. When we solidify it by applying pressure, although carbon dioxide gas is present in the gaseous form, but when we apply pressure and lower its temperature, that carbon dioxide gas changes into solid form, which is also known as dry ice. Next process, and the very important process, is evaporation, which is responsible for the conversion of liquid into gaseous form. The phenomena of, or the process of converting liquid into vapor form at any temperature below its boiling point is known as evaporation. And evaporation is known as surface phenomena, because when liquid changes into vapor form, the particles, after gaining energy, after gaining heat, they start gaining energy and they start vibrating, and they move in the upward direction from the surface. That is why evaporation is also known as surface phenomena. It's a 2-mark question asked in exam in so many times. Why is evaporation a surface phenomenon? This question asked in exam n number of times, and the reason for this is, as just now I have explained to you, the molecules which are present in the liquid, they start gaining energy by after getting heat. After getting heat, they start gaining energy and convert into vapor form and start moving in the air in the vapor form from the topmost layer of the liquid. This is the topmost layer of the liquid. That is why evaporation is a surface phenomenon. There are certain factors which plays vital role in the process of evaporation, and these factors are surface area, temperature, humidity, wind speed. These 4 are important factors which plays a vital role in the process of evaporation. First factor is surface area. More the surface area, more will be the rate of evaporation. It means evaporation and surface area, they both are directly proportional to each other. For example, if we take tea in a saucer or in a cup, it is easy for us to sip that hot tea from the saucer in comparison with the cup due to the more surface area. More surface area results in more evaporation. The particles of liquid starts evaporating, they start gaining more energy and converts into vapor form, which results in the cooling effect. While in a cup, due to less surface area, less liquid goes up in the vapor form and gives less cooling effect. Second factor is temperature. Temperature and evaporation, they both are directly proportional to each other. If we increase temperature, rate of evaporation is also increased. Because if we provide more heat, more temperature, the particles which are present in the liquid, they start gaining more energy and they start moving away from each other due to more heat. and they start getting more kinetic energy. As a result, they vibrate more and follow the zigzag path and start moving far away from each other. The next is humidity. Humidity is the presence of water vapor in the atmosphere. If water vapors are already present in the atmosphere and the vapors which goes up from the liquid, they'll get less space. As a result, the rate of evaporation low if humidity is more. So they both are inversely proportional to each other. If we increase wind speed, then what will happen to the rate of evaporation? If we increase the wind speed, the rate of evaporation also increases. More speed, more rate of evaporation. Because if the speed is more, the particles or the vapors of liquid which goes into the atmosphere, they start moving. As a result, the rate of evaporation also increases. So out of these four, surface area, temperature and humidity, these three are directly proportional to the rate of evaporation, and surface area, temperature and wind speed, these three are directly proportional to the rate of evaporation. If we increase surface area, if we increase temperature and if we increase wind speed, in all the cases the rate of evaporation also increases. While if more humidity, rate of evaporation is less. So this is the only factor which is inversely proportional to the evaporation. Evaporation is also known as a cooling effect due to this property only. When it gains heat, the particles of the liquid goes up in the form of vapors in the atmosphere and gives a cooling effect on the surface. There are certain questions, these are very important questions asked in exam n number of times. These are repeated questions and they ask in exam every time generally, and they comes in 2 marks, which is based on the applications of evaporation process. First is, why do we sprinkle water on the roof or open ground in summer? As we all know, during summer season, the temperature is quite very high, which makes the surface very hot. And if we sprinkle some water on the roof of the house or on the open ground, the water starts evaporating by gaining energy of the heat, and by losing, when it starts gaining energy, then the vapor starts moving up and those particles lose their energy from the ground, and it gives cooling effect which makes us feel comfortable. Second question is, explain how the rate of evaporation of a liquid is affected with increase in temperature of the liquid, decrease in exposed surface area, increase in moisture in the surrounding area, increase in wind speed. If we increase temperature, the rate of evaporation also increases. Decrease in exposed surface area, which means if the surface area is less, the rate of evaporation is also less. We are decreasing the surface area here. Now increase in moisture. Here moisture means humidity. If more humidity, the rate of evaporation is less. Increase in wind speed. If speed of wind is quite high or more, then the rate of evaporation also increases. So these are the factors which affect the rate of evaporation. There are certain physical quantities which we use to measure substances in our daily life, and these are basic quantities, they are units, and how we represent them, these are the symbols. First is temperature. Temperature, although it can be measured in Fahrenheit and Celsius also, but its SI unit is Kelvin. And what is this SI unit? That is Standard International Unit. Standard International Unit. These units are applicable worldwide. That is why we call them Standard International Unit. So the SI unit of temperature is Kelvin and its symbol is K. Quantity. Next quantity is length. Its unit is meter and symbol is small m. Mass is measured in kilogram and its symbol is kg. Weight is measured in Newton and its symbol is capital N. Volume is measured in cubic meter and its symbol is meter cube. Density is measured in kilogram per cubic meter and its symbol is kilogram per cubic meter. Pressure is measured in Pascal and its symbol is Pa. Density is mass upon volume. It can be measured by mass upon volume. And the unit of mass is kilogram and the unit of volume is cubic meter. So the density's unit is kilogram per meter cube. So these are the physical quantities which we use in our daily life. They are their SI units and how we represent them, or these are the symbols. I hope you like the session. Thank you.